So you're likely watching this on your mobile phone. A phone you may have had for years, or you may have just bought it. But have you ever thought about what's actually inside your phone? We're here at the University of Birmingham to investigate the true value of your phone. Before we go beyond your screen, let's talk about the most obvious part, the phone screen itself. It's not just glass. It contains a special element called indium. Indium tin oxide is a conductive ceramic that is transparent as a thin layer, making its properties ideal as a touchscreen. But where does it actually come from? Well, the good news is that indium is produced as a byproduct of zinc refining, a material from sphalerite we use in traditional batteries. But supplies may become exhausted in 10 years. Research is ongoing to find a sustainable replacement. We've got so used to touchscreens that they are now part of our ideal phones. But for our perfect phone, we also want it to be lightweight, using metals like aluminum, which is light, conductive, and malleable. So, why do we use heavy metals like iron? Think about the properties that make iron a special material. Beyond its mechanical properties, iron is magnetic.
Magnets play a fundamental role in your phones. They're used in your GPS so that you can navigate to and from places, and they're also used in loudspeakers and microphones, so you can hear from and speak into your phone, which is arguably quite important, and I'm sure a function you'd want out of your phone. So let's take a closer look at how magnets contribute to making your phone what it is. And to do this, we'll make a loudspeaker, which will essentially be a large-scale version of the exact one in your phone. So we start by attaching blue tack to the base. And to the blue tack, we attach the stack of magnets. Afterwards, we use elastic bands. We use the elastic band to suspend this coil above the magnet. Next, we take a piece of card. With this, we cut out a circle. Using the circle, we'll now make a cone. The cone will be attached to the coil. Ensure that the magnets are inside the coil. To test the loudspeaker, we'll be using a signal generator. As you can probably hear, our loudspeaker works. This is exactly what goes on inside your phone, just on a much smaller scale. It shows how essential magnets are to the components in our phone.
Perhaps the biggest thing that our phone requires is a power supply that suits our lifestyle. We want a battery that not only lasts long, but provides enough energy. Welcome to lithium. Lithium is the lightest of all metals and provides the largest energy density for weight, about 5 times that of traditional lead-acid batteries, which are commonly used to start car engines. Lithium-ion batteries are low maintenance too. They deteriorate slowly, and when the battery eventually fails, they cause little harm when disposed. Sounds great, but what are the hidden problems? Well, lithium is relatively abundant on Earth, but the process of extracting it is extremely energy hungry. Extracting lithium from spodumene involves crushing the ore, roasting at 1100 degrees Celsius, more grinding, and then acid leaching with sulfuric acid at 250 degrees Celsius. It's quite a nasty process. Estimates for total lithium reserves on Earth vary. However, it is generally believed to be around 17 to 20 million metric tons. That is less than half the amount of electronic waste generated worldwide per year. Plus, as the need for bigger batteries for vehicles arises, we will run out. Just because some things look worthless doesn't mean they can't be valuable. Take the old mobile phone in your drawer and recycle them. The elements they contain are rare earth materials, each special in their own way. So the next time you gaze at your mobile phone, reflect on its true worth, not just for you, but for the planet you want to live on.